Today we're going to be having a look at the alkali metals. So we've had a look at the structure and bonding of metals, and today we'll actually have a look at some and how they react in water. So we're going to work down the group. At the top of the group, group 1, we've got lithium, which I'm going to try and drag out a little piece here. Quite a decent sized piece. Now these are all stored under oil. They're quite reactive metals, so we keep them under oil so that they don't react with oxygen or with any water vapour in the air. But they are relatively soft, and we can cut them open, and hopefully you'll see there, just at the end, where it's nice and shiny, where you've got some fresh metal surface that we'd expect from metal. And if we blow on it, it'll begin to dull, and if we leave it for long enough, then you can see on the outside it would begin to get darker and darker. Now the reason we're able to cut through these metals is because the electrostatic forces between those particles are relatively weak. Lithium is a small 1+ ion, and so each atom contributes 1 electron to the delocalized C, and that means that you've got a 1+ ion, 1 electron holding the material together, and so it's just soft enough that I can cut it with a knife. Now I need to just wipe off the oil that's around the outside, but that's to stop it from tarnishing. And you can see by now that inside piece has gone quite dark, the same as the rest of it. So it doesn't take long for the oxygen to react. Now we're going to react it with water. You can see that it's not a very dense metal. It floats on the surface, and you can see there that it's fizzing and getting smaller. You can see a little trail given off from the lithium hydroxide, and on the smoke coming up the side here, the steam given off as it's getting quite hot. Now as that's reacting, we're releasing hydrogen gas, which is coming from the water, and the lithium is going into the solution as lithium hydroxide. So hydrogen and lithium hydroxide are the products, and the reactants were lithium and hydrogen. The metal's not particularly dense, it's less dense than water, so it floats, and those bubbles are causing it to move around. I'll let it finish. Now the next one we can have a look at, just further down the group, is sodium. So sodium's a slightly bigger atom. That electron is further from the nucleus. I'm going to take a piece of sodium out. Again, this one's quite soft, softer than the lithium. Those bigger ions means that that attraction is less, and I can cut this one up much easier than I did. The knife goes straight through it. And we get a decent sized piece that we can add. And again, stored under oil to stop it from reacting with the oxygen and water vapour in the air. Now because sodium's a bigger atom, that electron is further from the nucleus and it's less well held, which means it's easier to remove. And because it's easier to remove that electron, hopefully that's going to make it display slightly different properties. We'll see some similarities and some differences. So when we put the piece in, first thing you can see there is that it's fizzing much more vigorously. It's also got hot enough that that sodium has melted and formed a ball. Again, I've got hydrogen being given off as the gas, and you can see white trails behind there of sodium hydroxide. We're going to check the pH of the water just to see that something different has been made in a second. But you can see similarities, it's still less dense and it's floating across the surface of the water. So we've got same idea with density, it floats, it moves, it fizzes, or effervesces if you like to use fancier words. But slight difference is that it's more reactive, you see a more vigorous reaction, and we've also seen it get hot enough, a bit hotter, and hot enough to melt sodium into a ball. Now the last one we're going to look at, before we do that, we'll check that the water, and we'll see hopefully in there that the water, there we go, let's just put a little bit more in that, there we go. we can see that the water has become quite alkaline. So just using some universal indicator there to show the change of pH. We've produced sodium hydroxide instead of lithium hydroxide this time, making this solution alkaline. And the last one we're going to do is potassium. Potassium's the biggest atom that we're going to look at today. Massive piece there that you'll see, hopefully, potassium very, very soft. And I can cut straight through it really easily, and you can see it tarnishing already as soon as I've cut it with the knife. Put those bits back. Again, stored under oil, stop it reacting with oxygen and water in the air. A bigger atom means the electrons further from the nucleus, easier to remove, so hopefully we'll see something that's a little bit more reactive again. This time the sodium's got hot enough that it's actually allowed the hydrogen to catch fire. That traditional purple flame, there we go, almost exploding. Should we do one more of those? Potassium getting hot enough there that the flame was seen as the hydrogen caught light. Again, a piece of potassium got smaller as it reacted, went into the solution, produced potassium hydroxide. This time not only did it get hot enough to melt into a ball, but this time it got hot enough to make the hydrogen catch light. So one more time. The hydrogen there is burning around the piece of potassium, and a lovely explosion to finish off with. Right, I hope you enjoyed the video, and we'll answer some questions about that in a minute when you come back to the lesson.